Hello guys, welcome to my YouTube channel. Today I'm going to be explaining a question called largest sum of averages. Let me start off by explaining to you the question. So we are given an input array A. We have to divide A into at most k groups. Score is defined as the sum of the averages of each of these groups. Our task is to return the maximum possible score. Let us start off with some basics. So K is the number of groups basically which is given to us as an input which can be found at most. Now I am saying that if K is greater than equal to length of A, we return sum of A. Now why do we do so? To understand this, let us consider a scenario where K is equal to length of A and where each element is taken as a group. Now let us consider one of such groups. The group has only one element. So the average of the group is the element itself. Now the sum of such averages is nothing but the sum of the entire array. So the score here is the sum of the array itself. So we return this sum of the array as the score. Now one obvious question that comes to mind is why is this the maximum possible score? So if we give it more thought, the question is asking us the maximum sum of averages of the various groups in the array. If we give it more thought, we will realize that the maximum score across cases is itself sum of A. Therefore, we are sure that in this case, sum of A is the maximum possible score. Therefore, we return sum of A. Let us continue with some more basics. Let me define an array called A prime. So we have a recursive function f of I comma k. I will explain this recursive function ahead in the video. For now, let's just keep it in front of us. So let me define A prime now. A prime is an array whose elements are the elements of the array A from the index I to the end of the array. This I is defined as the recursive function f of I comma k. So now let us talk about the case k equal to 1. K equal to 1 means we can make one group. How do we make one group? By considering the array that we are considering at this moment of time as a group. So what will be the average of this group? The average of the array. The average of the array that we are considering at this moment of time is A prime. Its average is sum of A prime by len of A prime. There is no other group possible. Therefore, our final score is nothing but sum of A prime by len of A prime, and this is returned. I would like to explain one more very preliminary concept to you, that is of storing cumulative sums at the end of every index. Let us define an array pre-sum. Pre-sum is the sum of all the elements until the ith index, including the ith index in the array A. Suppose I want to find the sum between I and j, both included in the array A. I can find it quickly using this pre-sum array. It will be nothing but pre-sum of j minus pre-sum of I minus 1. Let me explain to you why. So if you see, pre-sum of j is the sum of all the elements until the jth index, represented by the blue part. Pre-sum of I minus 1 is sum of all the elements until the I minus 1 index, represented by the red part. If I subtract the red part from the blue part, I'll get the green part, which is a desired sum. Therefore, the sum between indexes I and j both included in the array A is pre-sum of j minus pre-sum of I minus 1. So let's get started with the approach. I have a recursive function called f of I comma k. What f of I comma k signifies? F of I comma k signifies the maximum score obtainable by making at most k groups between indexes I and len of A minus 1. The next slide shows how to compute f of I comma k. So before that, I have already explained two base cases to you, that is if k is 1 and k is greater than or equal to len of A. There is a third base case. If I is greater than or equal to len of A, return 0. This is a very obvious case because when we have covered all the elements, there is no other element left. So the remaining elements, there is no other element left. There are 0 remaining elements. 0 remaining elements contribute to a 0 score. Therefore, if I is greater than or equal to len of A, there are no elements left. So we simply return a 0. If there are no elements left, obviously there will be no remaining score. Therefore, we return a 0. Now how do we compute f of I comma k? When I say f of I comma k, I'm considering in the array A prime all the indexes, or instead of saying A prime, I can also say indexes of I to the end of the array A itself. Both are same. A prime and A within A from indexes I to the end are same. Let me tell this again. The array A from indexes I to the end of the array is same as A prime. So now let's say at any j between I and the end of the array, I'll show this in the picture. So see over here, this is I and this is the end of the array. At any j from I to j minus 1, I'll make a group. So see, there's a group made over here. The score that this group gives is nothing but the average of this group itself, which is signified by x. Now what we are left is an array A basically from the jth index to the end of the array. We have to find the maximum score of this array by forming at most k minus 1 groups. Why k minus 1 groups? Because one group has already been formed here. Why j? Because from the jth index to the end of the array. Let me explain how x is computed. Basically, x is the sum of the elements of the array A between indexes I and j minus 1 divided by the number of elements in I comma j minus 1, both included, because it's square brackets. X is pre-sum of j minus 1 minus pre-sum of I minus 1. This I've already explained before. Divided by the number of elements in I comma j minus 1. When we are given two indexes, the number of elements between them is nothing but the subtraction of the two plus 1. And the same logic has been applied here. So there's one case that we left out in f of I comma k, that is if I just make one group. When I just make one group in f of I comma k, it is nothing but all the elements from I to the end of the array A are in one group. The score of such a group would be sum of elements in the array A from I to len of A minus 1, both included, by a number of elements in I to len of A minus 1. How to compute this has already been explained before. So now here is a pseudo code for this. So first comes the base cases. Then basically from I to len of A minus 1, I choose a j. There's one part where I make the group, as I had explained earlier. The average of that group is added to the score, and the remaining part is computed using a recursive function with at most k minus 1 groups, which is from j to k minus 1. Okay, so why k minus 1? Because one group has been formed over here. Why j? Because the previous group was made ending at j minus 1 over here. So one of the possibilities is f of j comma k minus 1 plus this average. Let me explain this to you in greater detail. Let's say from 0 to I have, basically from 0 to end of the array I have, let's say from I to end of the array. Now, so let's say I have indexes from I to the end of the array. I'll choose any j in between, form a group over here, and the average of that group will be the score of this group that comes over here. The remaining from j to end of the array is computed by a recursive function by making at most k minus 1 groups. So that's why f of j comma k minus 1. Let me write this down and show this to you so that it becomes more clear. So let's say if I have I over here and this is the end of the array. So let's say this is len of A minus 1. So I'll choose an intermediate j here, form a group over here. The score that this group gives me is basically the average of this group, that is basically this, and the remaining part, that is from j to the end, is computed by a recursive function f of j comma k minus 1. K minus 1 because we can now form only at most k minus 1 groups, and why jth index? Because the previous group was made ending at the j minus 1th index. Therefore f of j comma k minus 1 plus this average gives us our final score. For different values of j, we will compute the answer this way and take the maximum. Also, the last case that I described, where we make only one group, we compare our answer with that case, that is here. When we make only one group, it's something like this. So I to again len of A minus 1, this whole thing is one group. So its score will be the average of this whole array itself, that is this over here. We compare our answer with this value and then return the answer. I had already explained all the cases over here before itself. In the pseudocode, I have combined all the cases and given a slightly detailed explanation. Now I will show you how to add dynamic programming to this. One way is to just memorize the results. So how do I memorize results? So basically, first I have to identify the dependent variables. The dependent variables are the variables which can uniquely define subproblems. In this case, many subproblems are computed again and again. So rather than computing the subproblems again and again, I will compute them once, store them, and when next time I'm going to compute the same subproblem again, I will just return the stored answer. In this question, the dependent variables are I, k. So now let's see how we can store overlapping subproblems. Before that, I would like to give a further detailed explanation of this again. So because it wasn't so clear earlier. So let us say I have indexes I to the end of the array len of a minus 1. At any j minus 1, I will stop. I will make a group. The score that this group gives us the average of the array from I to j minus 1. That is signified by this. The f of j comma len of a minus, basically then we have the array from j comma len of a minus 1. Now see, we have to find the maximum score in this array by making at most k minus 1 groups. So this will be given by f of j comma k minus 1. So again, I formed a group here. Now I have to find the maximum score in the remaining array from j to len of a minus 1 by forming at most k minus 1 groups. That is nothing but f of j comma k minus 1. Therefore, f of j comma k minus 1 plus this. So it is pretty simple. I form one group over here till j minus 1. The score given by this group is the average of the group, and also I have to find the maximum score from the jth index to the end of the array. Now this is not by forming at most k minus 1 groups here. So this is nothing but f of j comma k minus 1. Let me just repeat this last point. I have to find the maximum score from the jth index to the end of the array by forming at most k minus 1 groups, which is nothing but f of j comma k minus 1. Therefore, the addition of this gives us a score. The maximum score is chosen. This case is when this entire array is taken as one group. In that case, from I to the end, so the average of this array is itself the score that is contributed. We compare our answer to this, that is this, and return the final answer. I think now this is sufficiently clear. Let's get back to our memorization. So as I told earlier, the dependent variables here are I and k. So let us see how I store and return overlapping subproblems. Let's say if I comma k is in dp, it implies for this I and k I have already solved the problems and stored it in dp, so I can directly return dp of I comma k. At the end of the function func of I comma k, for every I comma k, I store the result with I comma k in a dictionary called dp. So basically, next time I want a result for I comma k that is in the dictionary, I can access it from the dictionary. So this last point, let me just repeat. For every I comma a, I compute the answer, store it in the dictionary. Next time when I see that this I comma k is present in the dictionary already, it means I've already computed the answer. So I return dp of I comma k simply. So this part is, if the result is already there, then return it. That is, if I comma k is in dp, then return it. At the end of the function, based on I comma k, I store the answer each time, which helps me in this is basically storing the results basically. I think it's pretty clear over here. The next approach that we have is the tabulation method approach. So basically, if you see in this approach, we solve new problems from the results of smaller problems that are stored in a storage structure. So the new problems are all obviously larger. Let me define a 2D DP array dp of ki. The max score obtainable in A up till the index I by making at most k groups is what dp of k comma I signifies. So dp of k comma I signifies the maximum score obtainable in A up till the index I by making at most k groups. Now let us discuss a base case where dp of 1 comma I is simply pre-sum of I by I plus 1. See, dp of 1 comma I signifies by making one group until the ith index the maximum score that you can return. Now if you are making one group until the ith index, it's nothing but the array until the ith index itself. So in this case, the answer will be the average of the array until the ith index itself, right? So that is pre-sum of I by I plus 1. You can read this for a further explanation. Now for k equal to 2 to k, see 1 was already done, so we'll start our the number of groups by 2 and go until k, which is given to us in the question. I is basically the variable I had defined earlier. So now let me explain to you this using a picture. So from 0 to I, we have to find the maximum score possible by dividing to at most k groups. Now see, if until, let's say I go until j, and from j plus 1 to I constitutes one group for me. Now the score that this group gives me will be simply the average of this group. The remaining part 0 to j is a smaller problem. Now here I am allowed to use only k minus 1 groups because one group is formed here. So this is a smaller problem which I would have already computed in dp of k minus 1j. K minus 1 because one group is computed here and initially we had k groups, so k minus 1. J here because initially we were computing until the ith index, but now it's only until the jth index. Clearly this is a smaller problem, so it's already stored in our array, so we can directly use this result. So it's dp of k minus 1j plus this average. The other answer possible is we take this entire thing from 0 to I as one group. So obviously the average will be the average of the entire array from 0 to I, that is pre of I by I plus 1. Each time we take the maximum and store it. In this case, we return dp of kn in the end. In the memoization approach, we just call f of 0 comma k and return our answer. So I think this was pretty much it. Now I will show you the code for both tabulation and memoization approaches. This is the memoization approach. So submitting it. It clearly worked out. Now this is the tabulation approach and this also worked out. You will see it works. Thanks for watching.